Welcome, I am Magnus Edholm, and when I'm not sitting in the studio, I drive the digital enterprise for Siemens and also communications and automation in US. Today I am joined by Kal Mos, who is Siemens' newly appointed Head of Research and Development. Welcome, Kal. How are you doing today?
I'm doing great, thank you very much.
Great having you. Before we start talking about innovation and the stuff that you're working on a daily basis, why don't you give us a short introduction of you and your background?
Absolutely. So as you said, I'm in charge of Siemens research and pre-development, and pre is important. I have been in my role for about 3 months now. And basically, my role is to bring the research from the labs into a product-ready state. So we can actually implement that in the industrial settings that we have at Siemens. Before that, I used to work for Google. And I was at Google building the software platform for deploying AI on the edge. So my role was to bring AI, the edge AI products that Google is developing, and bring them into the car, which is one of the edge products that we have. And before that, I worked at Amazon. And at Amazon, I led a global organization that built local search based on AI products. And that was a cloud-based product that is deployed and still deployed for millions of Amazon customers on all different platforms that Amazon has. Before that, I spent several years in automotive industry working for companies like Mercedes-Benz, like Renault, Nissan, and basically focusing on AI products for user experience and for autonomous driving. So through my whole career, I've been trying to bring research ideas into the real physical world to be deployed in critical missions, like autonomous driving or industrial settings and things like that.
Oh, that's impressive, Kal. That's impressive. So would you kind of agree with me that what you have been doing and what you are doing could be like, if I go back to the Stone Age, I mean, it's safe to say that the Stone Age didn't end because they ran out of stones. I know because I grew up on a farm. But the Stone Age ended because someone came up with a better way of using stones, turning into bronze. Would you say that that is kind of what you are doing and what you have been doing over the last couple of years?
That's a very great analogy. My job actually, using this analogy, is to look at all those people who are trying to find new usage of the stone and bring the best ones into the industrial settings. So how we can implement all these great ideas of how to use stones into our factories, into the great automation, into the critical industries that Siemens has. So this is what I'm doing.
Okay, and so when you do that type of development, I mean, it's probably a bit of a challenge to make sure that the new ideas that you have are perhaps not just incremental changes, but there are changes that has an impact, and also, and this I think is quite challenging, that there's also future-proof ideas. How do you go about doing that?
Yeah, absolutely. So the first thing that we look at actually is customer focus. So we focus on the customer challenges. And that is what inspires us to look for the right research. What are their main pain points? And it's usually in industrial settings, it's things like reliability, like for example, the latency, things that impact the usage of different machines when you bring them in the real physical world. So we start with that. We start with the customer pain point. And so that's our guidance. And then the other way we look at it also is how we can collaborate with the ecosystem. We have brilliant engineers inside Siemens, brilliant engineers, brilliant scientists. But at the end of the day, the technology is moving very, very fast, and we need to tap into the ecosystem around us. So we look at 3 areas in the ecosystem. We look at how we can collaborate with startups. We look at how we collaborate with universities, and we look at how we collaborate with our industrial and technology partners. So when you look at, for example, the startup collaboration, which is a very important part of our work, and it's already like we showcase that in our booth, we have a program called Siemens for Startup. And that program helps us to work with a startup in 3 different ways. The first thing is that we collaborate with them to empower them. We empower them with our tools. So we give them the tools that we have that they need to test their ideas in the real world. And by using these tools, they can actually start creating some proof of concepts. And at that point, we sit down together with them, hands in hands, to work with them in creating these proof of concepts and prototypes and pilots. So that's the second part, which is the collaboration. And then from there, when that idea is successful, we take it and we connect them to the right areas within Siemens where they can actually make this a product and release it in the world. So that's kind of the collaboration scheme that we have with startups. And then we have the other part, which is how we collaborate with universities. And we actually collaborate with like many worldwide universities, well-known, top-grade universities. At any point of time, we have like 35 different joint projects with universities. The one I want to maybe talk about a little bit is the one we have with Berkeley. So we work
but also, I know, before we move away from that, I mean, surely there are a lot of people out there in startups, in the business. How do they go about to get in touch with you? How can they become a part of that startup business? Is the Siemens Accelerator webpage, or how would they do it?
It is the Siemens Accelerator, yes. That's where they start, and they can start from the web page, but they can also reach out to our Siemens Accelerator program managers who can actually take them and connect them to the right area of the business. So that's the right way. And actually, for any startup who's out there today, they can look at our booth and connect with us at the booth, and they can be part of that program.
All right, very good, very good. And then you come back to what you said about you're working with, I mean, that we have been working with the universities over the last, I don't know how many years, and it's something that's obviously essential to our business. How do you do that? Do you go out to the universities and talk to them, or how do you make sure that are you supporting them with software, you say, the know-how? Is that something you do personally also?
Yeah, so, well, all of us, or most of us actually, in my area of work, we have a PhD, we have master's degrees, like all of us came from university, so we still have relationships with our professors and advisors. We are still connected to the ecosystem of the university. So either we know the professor, or either we look at the research that the professors are publishing, and then we collaborate with them in developing new ideas and bringing their ideas into reality. So the example I wanted to talk about today is with Berkeley, and basically with the robotics labs at Berkeley. So we work very closely with them in fine-tuning VLA models. So VLA is vision, language, action models. And these are basically the brains that runs the robotics and embodied AI today. So the idea there is that your language model is just for chatbots. So that's what it is. So you can communicate through language. But when you put AI in the physical world, you need now a vision, you need a perception, you need to kind of understand the environment around you, but you also need action so you can implement things. So you need all the three components. And to fine-tune that on industrial data, that's a very heavy and very important work we have with Berkeley.
Would you say also, I mean, I am an old engineer, I've been working with manufacturing, planning and simulation for many years, and there was a big part was also offline programming of robots. So what you're saying now is that you're taking, let's say, traditional automation, offline programming of robots, and you're taking it to the next era. You're developing. Is that what you're doing, so that you have cobots, it's going to be easy to program, you're going to have flexibility to work with a huge variety of different robot brands, or what is the reason?
Yeah. So robots today, and they are deployed everywhere in factories and every industrial settings, they have fixed function and fixed task. You today, you have to program them, and you have to commission them with very accurate instructions and scripts to tell them, okay, well, you pick up an object from that coordinates and put it in that coordinates, or you approach a certain setup in this way. And it has to be 100% accurate, because you need a very high level of success at the factory settings. So we take that from that kind of fixed environment, and we moved into a flexible environment where some variations in the function will be possible, and also some mix of different actions will be possible. So that's taking the robotic setup from a fixed way of doing things into a flexible way of doing things. And in order to do that, you need to kind of add intelligence. So you don't have to predefine everything from the beginning. You need to give the robot the possibility to actually figure out things on the fly. And in order to do that, you have to train the robot. So you basically create a model, an AI model, and you fine-tune that model on the environment. So actually the robot can understand the environment and interact with it. So that's the move from fix-it to flexibility.
So, and for that, so you're talking about a foundation model where industrial data is being gathered, and then you use the robot to train that. Is that also where, I mean, we always hear a lot about AI. It's generative AI, it is AI agents, it is physical AI. And physical AI, when you hear it, sounds extremely powerful. Is that what you're talking about? And can you perhaps also explain what physical AI actually means? I would be very happy to hear your explanation of that.
Yeah. So physical AI is exactly what it means. It's like when you bring AI from the digital world into the physical world. So you don't run AI in your own computer. You don't run the AI model in your own computer accessing some digital data. You actually bring that and put it in a device. That device can be a robot, can be a car, but a device that can interact with the real world.
Yeah.
So in order to do that, the first thing is that you need to provide that intelligence on the edge. So that device has to have its own intelligence, its own hardware to run that, and its own model to run that AI. So that's first step of this. But also that device, which is a car or a robot, has to have a lot of sensors to understand the real world. Vision sensors, tactile sensors, maybe proximity sensors, like lots of sensors in order to understand the physical world around it and interact with it. And then in real time, that device, which is a car or a robot, can try now to understand the world and then decide what to do next. Based on that understanding. So that's a physical AI. That's what we call by physical AI.
Interesting, very interesting. So, I mean, that's also what we're doing at Siemens. We talk a lot about combining the real and the digital world. We do that by creating digital twins and having data flow between all the people involved. It could be a horizontal flow, it could be a vertical flow of data. So, and at the end of the day, it comes down to collect data, analyze the data, and then use the data to continuously update everything that we are doing. Would you have like a practical example of what Siemens are doing with this? Are we using that technology? I mean, we are a big producer of our own stuff. We do that for so many, many years, as you know. And I mean, also a bit of a commercial break here. You can also visit us in our factories in Germany. We have in Hamburg, Erlangen, and Bad Neustadt, where you can see this actually taking place. So what would you say if someone's interested or if want to find out more about what we are doing? Is there a concrete example that you might have?
There are lots of examples. And as you said, they can visit us in Germany. But here on the show floor here at Siemens booth, you can actually see one real example of that. Which is an example of how you can, we call it teleoperation of the robots. So the idea is that in order to train and fine-tune the robots, we use what is called teleoperation. It's a standard technique that's been used in the industry for a while. And that is, you can do that through a virtual glass, or you can use this. And the idea there is that you actually control the robots to do certain action. And by doing that multiple times, the robot will learn how to deal with that action, and the model will be trained on that. So what we have on the booth now is that we have a glove, and that glove you can add in your hand, and that glove will enable you to control the hands of a robot. And the new innovation there is that you can feel what the robot is feeling.
Haptic and tactical feedback?
It has a haptic and tactical feedback. So when you actually try to hold on an object, in your hand as a human, you can feel the force, and you can decide how much you can pressure that object in order to hold it correctly. And that helps us very much in understanding this and training the robots to handle multiple different types of objects: solid objects, soft objects, objects that are irregular form, and using this data into our simulation pipeline, Siemens simulation pipeline. So you can actually simulate, you can validate, you can fine-tune this, and you can take it all the way into understanding and creating that model in a way that it's ready for production.
Fantastic.
All in a virtual world before you actually take it to the factory.
Excellent, excellent. I'm looking at the time and we're kind of low on it, but essentially it comes to start working very tightly with robots. Don't be afraid of them, you got to work with them. Look into the development of things. And if you're interested in finding out more about what we're doing with robotics, you can always visit on Siemens.com and you will find a lot more. You will have the glove, you will have the research, what Kal and his team are doing. Extremely impressive. For 5 seconds, what does the future look like? 2 sentences.
Well, the future is using virtual training and tuning into solving the real industrial problem.
Yeah.
And we're doing this, and we're helping all companies, big and small.
Fantastic. Kal Mos, totally nice to meet you. It was a pleasure having you here. I hope to talk to you more, and we should have at least another hour because I have a lot of other questions.
Would love
But
to do
with
that.
that, then we are signing off for this time. Thank you very
Excellent.
much.
Thank you very much. Appreciate it.